Welcome to today's session. And today we'll be looking at Punggol Secondary School, Secondary 1 Express, or rather G3, End of Year Examination, Paper 1. And moving on, after looking at instructions, as well as being aware of the mathematical formula, question 1. By rounding off each number to the nearest integer, estimate the value of this expression. Give your answer correct to one significant figure. All right. So what I'm going to do is I'm going to underline what's important in the question, rounding off each number to the nearest integer. Let's copy down the question first. An integer refers to a number that is not a fraction or a decimal. So if we round off 5.78, the nearest integer will be 6. So 6 squared in the numerator. 13.11, nearest integer will be 13. And 24.99, the nearest integer will be 25. And that's within the square roots. Now, let's work out the answer. 6 squared, that's 36. Square root of 25, 5. So 36 divided by 18, we end off with 2. And this is one significant figure. All right, let's move on to the next question. Consider the numbers below. Write down all perfect squares, so all. As we look at the list of numbers, it will be good for us to manually calculate those numbers that are in a surd form, surd meaning in a root form, or is irrational, for example, 4 pi. So let's work out square root of 19. Square root of 19 gives us 4.358. Cube root of 125 gives us 5. 4 pi gives us 12.566. Okay, and from here, all perfect squares are basically numbers that can be square rooted to give you an integer value. So negative numbers are definitely out. Negative numbers are not perfect squares. Okay, square root 19 is not a perfect square because it does not give us an integer. Cube root of 125, it's not as well. 4 pi, no. 16, yes, because 16 is actually 4 times 4, okay? Which is 4 square. So our answer, 16. Next, write down all irrational numbers. And irrational numbers are basically numbers that cannot be expressed as a fraction. So we have root 19 as well as 4 pi. The other numbers can be expressed as a fraction. So allow me to share with you. Negative 4 can be expressed as negative 4 out of 1. Cube root of 125 basically gives us 5, which is written as 5 out of 1. And 16 can be written as 16 out of 1. Okay. Now, moving on. Question 3. Consider the following numbers. Arrange the numbers in ascending order. Ascending order means it is small to large. Now you realize that these numbers that are listed are given in various forms, and we are going to convert all of them into decimals so that arranging them is most easy. So if we have 88%, that gives us 0.88. Negative 8 out of 100, negative 0.88. 0.8 with a dot on top, it will be 0.888. And negative square root 64 will give us negative 8. All right. So we see that actually in this list, there are two numbers that are negative and two numbers that are positive. Now, between the negative numbers, which is the smaller one? So you can see you have negative 0.88 and negative 8. Well, negative 8 is the smaller. So okay, perhaps what I will do first is I will list them down. So this is the smallest, followed by negative 0.88. Then from then on, I will move on to the two larger numbers. So we have 0.88, 0.888. Now you realize that the difference is that 0.88 just pauses there, and thereafter there is no more digits. If you want to put a digit in a space that has got nothing, it has to be a zero. So 0.880, 0.888, what's smaller is 0.88. Okay, so this will be in place of number 3 and 4. Now that we have our sequence, we can list it out in the original form of the numbers. So we have to be very careful not to put down whatever I've written down in blue, but the original one instead. Okay, so the first one is negative square root 64. Number 2, negative 88 out of 100. Number 3, 88%. And number 4, 0.8 with a dot on top. Okay, now, next one. Factorize the following expressions completely. So looking at this question, factorizing means that we want to bring out this common factor of all terms in the expression. So let's look at the coefficients first. We have 6, we have 15, and we have 36. So these three numbers can be divisible by 3. I'm going to bring out 3. And moving on, if we were to look at the variables, A is found in the first term but not the others. B is found in the first two terms but not the last. So there are no common factors in terms of the variable. We just extract out 3 as the common factor. So in each of these terms, I'm going to divide them by 3. And let's do another check to see that when 6AB is divided by 3, we get 2AB. Negative 15B divided by 3, we get 5B. And positive 36 divided by 3, we get 12. Okay, so this is the answer. Moving on, part B. 4 bracket x minus 5y plus 3z bracket negative 5y plus x. So what we can do here is if you notice that this first part of the expression is the product of 4 and x minus 5y, and the other part of the expression is the product of 3z and 5y plus x. Within the bracket, you realize that the terms are the same. So what I'm going to do for the next line is I am going to shift the terms within the second bracket. So instead of negative 5y plus x, I am going to write it down as x take away 5y. Now you realize that again, within each of these compartments that make up the full expression, these are common in both parts of the expression. I'm going to extract them out as common factors. So taking out x minus 5y, what have I left in this first part of my expression? Basically, it's 4. Okay, going to copy down the positive sign. And in the second part of the expression, if I were to divide it by x minus 5y, I will end up with 3z. So this is my answer. Okay. Moving on, let's take a look at the next question. Every month, Ben spends 50% of his salary on food, a quarter on entertainment, two-fifths of the remainder on investments, and saves the rest. Find the fraction of money that Ben saves. Okay, now let's see. I'm going to list them down so that the amount of information is written in an organized manner. We have food that would make up 50%, one quarter on entertainment. So one quarter means a quarter of 100%, which takes up 25%. Two-fifths of the remainder. Because of the word remainder, let's find the remainder first. Total amount of salary being 100%. If we take away 50% and 25%, the remainder will be 25%. Now I'm going to find two-fifths of this 25%. That will be for investments. Two-fifths of the remainder. And that makes 10%. Okay. Now we can find savings already. Because let's see, when we find the remaining amount, which is 25%, out of it, 10% is taken out for investments. So savings will be 25% minus the 10% used for investment. That gives 15%. However, the question wants us to find it in a fraction. So 15% is 15 out of 100. Let's put these values into our calculator and we will have it right away in simplest form. Okay. Now, let's take a look at part B. So part B mentions that if Ben saves $600, find his monthly salary. Okay, let's see. Based on part A, we know that his savings is actually 15%. His savings also make up 3 out of 20 of the salary. And that's actually $600. Allow me to put this one down. Okay, now the monthly salary would be all 20 parts. So let's proceed on to find 1 out of 20 of the salary. Followed by 20 out of 20 for the entire salary. So we have 20 times. So the salary will be $4,000. Right. Moving on, let's have a look at question 6. Simplify 2a, take away bracket 3 minus 5 bracket a plus 2, close bracket, and close square bracket. Let's copy down the question accurately first. Now, first and foremost, we will have to simplify what's in the innermost bracket. So we have to take -5, multiply into each of the terms within the brackets, and we will have -5 times a, we have -5a, -5 times 2, we have -10. Following that, let's simplify the terms within the bracket. We have 3, take away 10, that gives us -7. And moving on, we are going to remove the second bracket by multiplying -1 into each term in the bracket. So -1 times -7, positive 7. -1 times -5a, positive 5a. Simplify, this will be it. All right. Next question. It is given that P equals to Q squared plus 4 out of 5R. Find P given that Q is -3 and R is 15. So let's sub these values into the equation. And every time we substitute a value into the unknown, into the variable, we will bracket it. So Q square means that we have to bracket the -3 that we are substituting. Okay. Square it. Okay, now let's simplify. So pressing -3 bracket, square into the calculator, end up with 9. 4 out of 5 multiplied by 15, we get 12. So just bear in mind that it is important for us to put the number that we are substituting into the equation within a bracket all the time. Now, what happens if we do not put a bracket? Then it will be troublesome, especially when we come to substituting negative values. When we substitute negative answers, negative values within an expression, and then it's squared, negative and negative will end up in positive. Yeah. So putting it into the calculator without the brackets, you will risk ending up with the wrong outcome, the wrong output after you have squared it. Let's move on. Question 7. Express 28 minutes as a percentage of 2 hours and 45 minutes. So we will have to change, we will have to first and foremost put it as a proportion. That means we write it as a fraction before we convert it into a percentage. So we have 28 minutes out of 2 hours, 45 minutes. This is the proportion, and we multiply by 100% to convert it into a percentage. Now, you realize that the fraction itself has got units that are not congruent to each other, right? They are not the same. So what we need to do is we will need to convert both numerator and denominator into the same units. And most of the time, we convert it into the smaller units so as to avoid fractions and decimals. So 28 minutes, we continue to leave it as 28. However, 2 hours, 45 minutes, let's convert it into minutes. So 2 hours will be 2 times of 60 minutes. And we add another 45 minutes. Giving us a total of 165 minutes. And you realize this is more effective for us to work out the percentage. Let's put our values into the calculator. And we will end up with 16.969, 69697. Okay, you can choose to write down the entire list of numbers in a calculator, or you could give it up to 4SF, thereafter rounding it up to 3SF. So the third SF is in the number 9. We will have to round it up because the next SF is more than 4. So it'll be 17.0%, rounded off to 3SF. Now the next one, when a number, we don't know which number, x is increased by 3%, the result is 412. Find x. Now any original number that is given is always 100%. So when it's increased by 3%, that means it's 103%, being 412. In order to find x means that we need to find 100%. So 1% will be 412 out of 103. And finally, 100% would be to multiply this fraction 100 times over. So we will end up with 400. Let's move on. Okay, question 8. Given that x to y is 1 to 2, y to z is 3 to 5, find x to y to z. So let's put down the information. And you will realize that what seems to repeat is that of the quantity of y. So between 2 and 3, they both belong to y. We will need to find the lowest common multiple between these two numbers so that they'll be the same, as well as to help us find equivalent ratio for both ratios individually. So between 2 and 3, our common um, lowest common multiple is actually 6. So we will end off with a 6 at the end. Now for the first ratio, from 2 to 6, we need to multiply by 3. And we will do so for x as well. So that gives us 3 to 6. For the second ratio, from 3 to 6, we multiply by 2. And therefore, for z, we also multiply 5 units by 2 to give 10. And therefore, x to y to z will be 3 to 6 to 10. Moving on, a brand of honey is sold in 2 different sizes at a local supermarket. The volume of the honey and their price is shown below. Right, so for size A, it's $8.90 for 750 milliliters, while the one that is for size B is $4.90 for 350 milliliters. So which size would give you a better value for money? Better value for money means you don't pay as much, but you get more, um, yeah, the same amount of volume of honey. So let's consider size A. We have 750 milliliters being sold for $8.90. Let's find 1 milliliter. So that will be $8.90 divided by 750. And that would give us 0.01186. Giving it up to five decimal places. Okay, that's for the cost of 1 milliliter of honey. Now are going to move on to consider size B. And for size B, it'll be 350 milliliters for $4.90. So let's again find how much 1 milliliter of it costs. So we have $4.90 divided by 350. And I end up with 0.014. Okay, now let's do a comparison. Okay, same amount of honey, but which one is cheaper? So we have 0.011, 0.014. We can see that size A actually gives you a better value for money. So how should I write it? I could write it by convincing the marker that 0.01186 is indeed less than the cost of 0.014. So size A gives a better value for money because it has a lower cost of 0.01186 as compared to size B 0.014 for 1 milliliter of honey. Okay, yeah. So I think that it will be helpful for us to actually list down uh, the cost itself as well as what we are comparing it to. In this case, it's a comparison of 1 milliliters of honey. Okay, now why am I talking about size B over here? Because the question talks about better. When it's better means that there is a form of comparison. When we are just talking about size A and size A alone without considering explaining what we have found about size B, then are we really trying to explain in totality? Okay, so when we want to compare something, it's better compared to that something else. In this case, it is size B. It is that size B that we want to compare our readings to. Okay, yeah. And it is also more credible for us to put down the cost per unit volume. We don't just say, oh, this is of better value, but well, I think it's so, without any substantial proof or evidence. Okay, so in mathematics, we talk numbers, we reason with numbers, and of course, something that is mathematically sound. Moving on, let's have a look at question 9. The line L1 is drawn in the grid below. So write down the y-intercept and gradient of line L1. So y-intercept will be where the line actually crosses the y-axis. Okay, and this is 0, 4. Okay, coordinates wise is 0, 4, but the y-intercept itself is just 4. Now, gradient, we will have to consider it being rise over run. So first and foremost, this is a line that is sloping downwards. I'm going to put the negative sign first so that we don't miss out that the gradient is actually negative. Now, rise over run means that we will also need to consider two points on the line that intersects very nicely within the grid. Okay, so I would consider this point and this point over here, and to draw a right angled triangle down from the higher point. Okay, and align itself with the lower point and draw a line across. Okay, so this is the right angle. Now, what is my rise? So from 0 to 4, my rise is 4 units. And my run will be also from 0 to 4, it will be 4 units. So rise out of run is 4 out of 4. Gradient, negative 1. Moving on, another line L2 has the same y-intercept as L1. Same y-intercept. Now, same y-intercept means that if we were to compare with the answer in part A, it's 4, right? It passes through y equals to 4. On the grid above, draw and label line 2 if the gradient of line 2 is 2. Okay, the gradient of line 2 is 2. That means it will be, let's say in a general equation, it will be y equals to mx plus c. So now if we know that the y-intercept is 4, c is 4, right? Gradient 2, so it's 2x plus 4. How are we going to draw and label this line? So what we can do is we will need to know the exact coordinate points of them. And what better way than to draw a table and come up with the coordinates. Let's see what would be good values of x that we can put down. You can see that x is range from -4 to 6. So what I'm going to do is I am going to choose values of x that are not too big, not too small, perhaps easy to calculate. I'm going to choose -1, 0, and 1. Okay. And then I'm going to substitute these values into the calculator, into the equation and work it out through the calculator. Okay, -1, 2. Let's find it. Let me use another color. -1, 2. So this is the point. 0, 4. So this is the point as well. And 1, 6. Okay. So using a ruler and a pencil, we will have to draw a line through these three crosses. Yeah. Okay, so it will look something like that. I'm doing it freehand. However, please do so with a ruler. Okay. Okay. And not enough. We have to label the entire equation of the line. So y equals to 2x plus 4. Okay. So that will be for question 9. Question 10. When written as a product of prime factors, 132 is represented by 2 squared times 3 times 11, and express 1350 as a product of its prime factors, giving your answer in index notation. So let's use prime factorization to break it down. Right. So we have 2 multiplied by 3 cubed multiplied by 5 squared. Let's just quickly do a simple check by putting in the index notation values into the calculator to make sure that it's 1,350. Okay, now we are on the right track. So we have 2 times 3 cubed times 5 squared. Part B. Hence, find the greatest integer that will divide both 132 and 150 exactly. So if it's the greatest integer, here we are referring to what you call HCF. Thus, this number is going to divide 132 and 1,350. Okay, so let's just put down the index notation for both numbers. Square times 3. Okay, so HCF, let's compare. So we have two common factors. 2 square, 2. What is common is actually 2. 3 and 3 cube. So from here, we work out HCF to 6. Now, in order to find the LCM, we are required to put down all prime factors to the higher power or highest power. So in this case, we have 2, 3, 5, and 11 as our prime factors. And with the higher power, this is what we have. And let's input this into the calculator. Okay, to 29,700. Okay, next. The smallest integer k such that 1350k is a perfect cube. So if we have 1350k, it is broken down into right? And for it to be a perfect cube, what happens is that the powers of each prime factor have to be multiples of 3. So if you look at the first prime factor, that is 2. 2 means 2 to the power of 1. To bring it to a power of a multiple of 3, that means it'll be 2 to the power of 3. We need to multiply it by 2 more times of 2 to make it 2 to the power of 3. Now, 3 to the power of 3 is already having a power that is a multiple of 3. We are not going to add any more powers of uh, any more 3's to this. However, for 5 to the power of 2, we can bring it up to 5 to the power of 3 to make it a perfect cube. So that would be to multiply one more time of 5. So what's k? K would be the product of these numbers. 20. Now let's also do a check. If k is 20, when we take 1354 times 20, we get 27,000. We do a cube root. We should get a positive integer. And in this case, it will be 30. Okay. All right, let's move on. Next question. Kenny cycled from town X to town Y at an average speed of 15 kilometers for 80 minutes. So this is cycling. After reaching town Y, he rested for 25 minutes before cycling another 5 kilometers from town Y to town Z in 45 minutes. Find the time he would reach town Z if he left town X at 10:45. Okay, so it might be a good idea for us to draw the timeline so that the information that's in the question may be put out to view more easily. So we have town X, we have town Y, and we have town Z. From X to Y, it's at an average speed of 15 km per hour. Okay, I'm going to put down average speed. 15 km per hour time 80 minutes. At this point, I would like to convert it into hours because the unit for speed is km per hour. So to convert it into hours will be 80 out of 60. After reaching town Y, he rested for 25 minutes. I'm going to put down the rest time. 25 minutes will be 25 out of 60 hours before cycling another 5 km. Okay, so from town Y to town Z, The distance is actually 5 kilometers and the time taken is 45 minutes. So changing it to hours, it'll be 45 out of 60 hours. Okay, so some students actually, I'm not sure if you or your friends do struggle with converting minutes into hours or hours into minutes. And then it can be quite a challenge when you see that when you hit the calculator, you end up with a decimal. So the easier way or the more straightforward way would be to just change it into a fraction by putting it as out of 60. Yeah, the calculator will sort this out later in your later workings. So not to worry, just leave it out of 60. Same for rest time, same for the time taken for the second half of the journey. So find the time he would reach town Z if he left town X at 10:45. Okay. Now, thing is that we have all the duration for the various parts. But let's add up the duration, okay? So total duration, we have 80 out of 60, 25 out of 60, and 45 out of 60. And all these are in hours. Okay, that gives us a good 2.5 hours. Okay, I'm going to put it as 2.5 hours or 2 hours and 30 minutes. Yeah, as you can tell, 0.5 is basically halfway through an hour, right? So that is 30 minutes. So the time that he will reach will be 2.5 hours from 10:45 a.m. Let's go 2 hours. That would give us up to 12:45 p.m. And 30 minutes later, that will be 1:15 p.m. Next, find the time he traveled from town X to town Y. Pardon me, find the distance he traveled. So from town X to town Y, we have relevant information that we can use. We have average speed and we have time. So the distance traveled would be speed times time. 15 multiplied by 80 out of 60. And this time round, everything is aligned. The units, hours, kilometers per hours. Okay, we're good to go. So we end up with 20 kilometers. Finally, find Kenny's average speed for his journey from town X to town Z. So the formula for average speed will be to take the total distance divided by the total time. Okay, let's consider the total distance first. The distance from X to Y, as we have found just now, it's 20 km. Next half of the journey, 5 km. So that makes a total of 20 plus 5. Total time, just now we have found out to be 2 hours and 30 minutes or 2.5 hours. So from here, we should be able to come up with the average speed. So we end up with 10 kilometers per hour. Next question. In a hexagon, three of the interior angles are 99, 105, and 120. The remaining interior angles are given respectively. Find the value of x. Okay, now, so this question talks about interior angles all the way. And we are also told that it's a hexagon. So how many sides has a hexagon? 6. So let's start off by finding the total interior angles of a hexagon. So we will use the formula n minus 2 times 180 degrees. In this case, n is the number of sides of the polygon, which is 6. Now, we are given all angles, just that some have exact values and some are in terms of x. I'm going to put them all together, find its sum, and equate them to 720. Following that, let's reorganize the terms on the left. And I'm going to place all the other integer values on the other side of the equation. Let's just double check. Take away 29 plus 19 minus 35, take away 99, take away 105, and take away 120. Okay, 9x. Okay, let's work out the right-hand side. So from here, we can find the value of x, 39. All right. Now, next, let's take a look at the largest interior angle of the hexagon. So what is the largest interior angle of the hexagon? Let's do a comparison. We have, okay, the known ones, the largest interior angle will be 120. It's definitely not going to be 99 and 105. Comparing the other three, where it is in terms of x, you will realize that 4x plus 35 is going to be greater than 2x plus 29. Okay, due to the fact that 4x is twice of 2x. 35 is greater than 29. So definitely 2x plus 29 is less. Now 4x plus 35 is also more than 3x minus 19 because 4x is greater than 3x. Yeah. And if it's already greater and you're going to remove another 19 degrees from it, won't 3x minus 19 be definitely going to be less than 4x plus 35? So what I'm going to do is I'm going to sub the value of x equals to 39 into 4x plus 35, see what it leads to, and compare with 120 degrees to see which is the greater angle. So let's see. Plus 35. Oh, 191. Okay. And it is greater than 120. So the largest interior angle is indeed 4x plus 35. So I'm going to put it down, 191 degrees. All right. Moving on. Abbas claims that the diagram below shows part of a regular polygon. Is he correct? Now, we are not so sure how many sides this polygon has, except that we are given the interior angle of 3 of it. We will only know whether it is a regular polygon if all of the exterior angles multiply consistently to give 360 degrees. So let's find the exterior angle. Okay, this is based on angles on a straight line. So 180 minus 128, we get 52. Now, all exterior angles would make up 360 degrees. And if it is a regular polygon, we have a certain number of times of 52 that will make up 360 degrees. Okay, so let's find out and see whether n is a positive integer. Oh, okay. So I will end up with 6.92, and definitely it is not a positive integer, right? So Abbas' claim, do you think it is correct? Is he correct? Abbas is not correct because the value of n is not a positive integer. All right. So question 13. In the diagram below, BCD is a straight line and AB is parallel to DE. Given that angle ABC is 56 degrees and BCE is 112 degrees, find, stating your reasons clearly, angle BDE. So BDE will be this angle over here. And you will realize that, oh, okay, this angle here is quite near to a parallel line, right? One of the parallel lines. Yeah, and you realize that we can easily find it through alternate angle. So angle BDE is equals to 56 degrees, alternate angle, and is due to AB being parallel to DE. 56 because of alternate angles where the line AB is parallel to the line DE. Okay, now reflex DCE. DCE, okay, is this angle. Reflex will be this, that's outside. Now you realize that if we have 112 as part of it, we would just need to find a portion of the other side of the reflex angle, add it up to get to the answer. Okay, and you realize that this is a straight line. So straight line means that it is 180 degrees. So reflex angle DCE will be 180 degrees plus 112 degrees. Okay, it's false. Okay. I will have to mention that BCD is a straight line. Okay, and BCD plus BCE equals to 180 degrees plus 112 degrees. Since BCD is a straight line. Okay. Hmm. Yeah. Okay, so that can be used. Hmm. Okay. Now let's see the next one. Daniel claims that triangle CDE is an isosceles triangle. Explain why he is correct, showing your working clearly. CDE. So before we can say whether his claim is correct, we will need to find another angle. So if BCD is a straight line and we have 112 forming one side of the straight angle that makes up the straight line, the other side would be 180 degrees minus 112. Okay, so that's DCE. So we will end up with 68 degrees. And let's also find out the angle CED. Minus 68 minus 56. Sum of angles in a triangle. End up with 56. So this missing angle is 56 degrees. And because of this, we can see that CD is equals to CE in terms of its length. Okay, so CDE is an isosceles triangle because angle CDE is equals to angle CED, making which two lines the same? CD to be equals to CE. Right. So this concludes paper one. And join me again to have a look at paper two. All right. Take care and see you.